Algebra 1, Lesson 43, Part A is least common multiple. You've done these before. We're just reviewing how to do them using all numbers, and then Part B is going to include variables. So, in the past, when you were finding common multiples, here in example 1 we have, well, first of all, the least common multiple is the smallest number that it divides evenly by all the given numbers. So in example 1, we're looking for the lowest number that divides evenly by 8, 15, and 100. And when you started doing these, you would have listed out the first few multiples of 8, the first few multiples of 15, the first few multiples of 100, and keep making those lists longer until the same number appears in all three lists. Depending on what the numbers are, that could be very short, but it could also be very long and tedious. So we're going to look at some other methods of finding the LCM. It's always going to involve prime factorizations. I have two different methods to show you. In method 1, which we use for example 1, it says, write the prime factorization of the first number. Okay, we're going to put a prime factor in each box on this grid that I made here. 8 is 2 times 2 times 2. Then we write the prime factors of the other numbers, being sure to put common factors in the same column. Okay, well 15 is only 3 times 5. There are no 2's. So I'll go out here and put 3 times 5. 100, that is 4 times 25. So that's 2 times 2 times 5 times 5. Okay, write the factor here. So whatever number is in that column, we're going to write it, even though the columns aren't full. 3, 5, 5. Multiply these factors. That will be the least common multiple. And I'm looking here, 2 times 2 times 2 times 5 times 5. That's 100. Okay, so I have 2 times 3, which is 6, times 100. So the LCM is 600. I would have had to make my list for multiples of 8 and 15 pretty long before I got to 600. So this is a lot shorter. Okay, now there's a way that's even shorter than using the table. And that we're going to look at in example 2. Now we're finding the LCM of 30, 75, and 80. And I already have this listed here. So now we're going to write the prime factorizations of each of these numbers using exponents. Okay, 30 is 2 times 3 times 5. No exponents needed, they're all ones. 75 is 3 times 25, so it's 3 times 5 squared. And then 80, it's always okay to do a tree. I'm going to cheat a little there. 8 is 2 times 2 times 2. And 10 is 2 times 5. So I have 2 to the 4th power times 5. Okay, now over here in the box, it says take the greatest power of each prime factor and multiply them. So the LCM, I look at all the different prime factors I have. I have 2's, 3's, and 5's. I'm leaving a little space, because then I'm going to go back and look at all these, what's the highest exponent on any of the 2's? 4. There's only that one 3, and the highest exponent on the 5's would be a 2. Okay, so this is 16 times 3 times 25. That number is the least common multiple of 30, 75, and 80. Alright, so since I'm not going to be using a calculator, I'm going to do this strategically to try to do easier multiplications. 2 to the 4th, okay, so here's 2 squared times 2 squared times 3 times 25. And I did that because 4 times 25 is 100. So I have this other 4 times 3 is 12 times 100, so 1200. And that's it. Okay, here's another one. These numbers are quite a bit larger. So let's do this the same way. Oh, by the way, I did want to mention the reason for the highest exponent, if you take a look at the table when we had that, we're using all three twos here, factors. That was the largest number of twos that was used. And here we're using both fives. That was the largest number of fives that was used. In order for this number, our answer, to be evenly divided by all of these, it has to include all the factors. So it's that. When we were doing greatest common factor, it was for greatest common factor, use the lowest exponent. Now for least common multiple, you use the highest exponent. So hopefully that's easy to remember. Now for 560, okay, so 560 is 56 times 10. That's 7 times 8, and I know 8 is 2 times 2 times 2. Okay, so 7 times 8 is 56 times 2 times 5. Okay, so 560 is 2 to the 4th power, I almost missed one, times 5 times 7. 588, let's see, 588, I know that divides evenly by 4, so that'd be a slightly quicker way of splitting it. 4 into 588, 16, 147, okay, 11, 12. The digits in 147 add up to 12, which is divisible by 3. That means 147 is divisible by 3. Okay, so 12, that gives me 49. So that means 588 is 2 squared, that's the 4, times 3, and then 49 is 7 squared. So see, I didn't take my side work the whole way down to primes, but enough that I can write the prime factorization here. And then 1,250, well, that's 125 times 10, and I know that that is 5 times 5 times 5, and 10 is 2 times 5, so we have 2 times 5 to the 4th power. So the LCM is going to include all the different prime factors. We have 2, 3, 5, and 7. Again, I'm leaving a little space so I have some room to put the exponents in without crowding things. Okay, the highest exponent on my 2's would be a 4. There's just that one 3. 5 to the 4th, and 7 squared. And see, if I put my prime factors from smallest to largest, it's easy to find things when I'm looking for them for the exponents. And then I need to multiply that, and that will give me the LCM. Okay, and I'm still going to be strategic about this. So, 2 to the 4th again, that's 4 times 4, and 3, and 5 squared is 25, so this is 25 times 25, and then 7 squared is 49. So, 4 times 25 is 100. That 4 times that 25 is also 100. And then I just need to see what 49 times 3 is. Well, actually, if I look over here at my side work, 49 times 3 must be 147. Okay, so the LCM is 147 with 4 zeros after it. 1, 2, 3, 4. Put some commas in to make it easy to read. And that is the least common multiple of 560, 588, and 1,250. Okay, on to part B. One nice thing about when variables are put into these problems, most math books keep the coefficients fairly small, so it's easier to find the LCM of the coefficients now. Okay, so we're still writing factorizations, only now it's going to include letters. Okay, so for the first one, we're finding the LCM of 15a squared b, 15a squared b, and 10a b to the 3rd. And we're going to do what we're doing with most of the examples on the other side is write prime factorization with exponents. So we have for 15, 3 times 5, and then that's times a squared times b. 10 is 2 times 5 times, and then with the variables a times b to the third. The LCM will include all the different factors. We have 2's, 3's, and 5's, and then also a's and b's. Okay, 2 is to the first, 3 is to the first, 5 is to the first. A, the highest exponent is 2, and for b, the highest exponent is 3. So 2 times 3 is 6, times 5 is 30. A squared b to the third. That's it. On the next one, see, very small coefficients. 4 x squared m, 6 x to the third m. All right, so we have 2 squared x squared m, and 2 times 3 x to the third m. The LCM, okay, so we have 2 with its highest exponent times 3 times x with its highest exponent times m. 2 squared is 4. 4 times 3 is 12, so it's 12x to the third m. And we have 1 left. By the way, for whatever reason, all of the examples in Part B only have 2 different terms that we're finding the least common multiple of. There could be 3, there could be more, but you do them the same way. So we have 12x squared am squared and 14x to the third am to the fourth. 12 is 4 times 3, so that's 2 squared times 3, x squared am squared. 14 is 2 times 7, and then x to the third am to the fourth. The LCM will include 2's, 3's, and 7's. The highest exponent for 2 is a 2. 3 and 7 reach just to the first power. And then we have x to its highest exponent. A would also be to its highest exponent. There's just 1 on both of those. And then m to its highest exponent. All right, so 2 squared is 4. 4 times 3 is 12. And I happen to know that 12 times 7 is 84. You could always do side work for that. X to the third, am to the fourth. And that's all there is to that. Have